Hi everyone, let's start solving today's lead code question 1466 reorder routes to make all paths lead to city 0. Yes, I agree this problem is not very much intuitive. You need to spend a lot of time to approach the solution of this problem. You need to think in a lot of aspects to get to the solution of this question. So let's try to understand the question first. So we have given n cities and which are labeled from 0 to n minus 1 and n minus 1 roads such that there is only one way travel between two different cities. This is a very important point, like there are n minus 1 roads and there is only one way to travel between two different cities. What does it simply means? If there are n nodes given to me and there are n minus 1, if I am say n vertices and n minus 1 edges, so there is, if I pick any two random nodes, there is only one way possible, or there is only one edge will be present between them. And what I simply mean by that is, if there is A and there is B and there is a C node, so B, if there is a node connected between A and B, there cannot be a different node connected from B to A. No, there is only one way possible because the graph should be called to a complete connected graph. All and there are n minus 1 edges present. There is only one. There will be only one edge present between any two nodes of the graph. Okay, so there will be any edge from A to B or A to C in any direction. Okay, so this is my observation. Now, okay, now what we need to achieve in this question, we need to achieve, like, if I start traversing from any node in the graph, I should reach the 0th node, and there is a solution possible, like I can reach the 0th node if I swap the edges between the cities. Okay, so let's understand the example first. So there is a outgoing edge from 0 to 1 and 1 to 3. Okay, so if I am at city 1, can I reach city 0? Yes, by swapping this edge. And if I am standing at city 3, I can reach 0 by swapping this edge 3 to 1, and from 1 to 0 I can reach 0. And if I am standing at city 2, yes, I can reach 0 by 2 to 3, 3 to 1 and 1 to 0. Same as 4 to 5. So in this question we need to return the minimum number of swaps we need to make to reach 0 at city from any another city. Okay, so I will show you a very simple solution that you can approach uh, to solve this problem statement. Okay, let's try to solve the problem statement from this particular example only. Let me try to erase this thing so you will get a proper idea. You need to spend a lot of time to analyze this problem if you feel this problem is very hard. Yes, and if you did not spend much time, you can stop the video now and you can analyze a problem statement as much as you can. Okay, if you're continuing this video, let's see. So what we can observe now, I need to reach a city 0. Okay, so from where I can reach the city 0, if their neighbors of this city 0, if I can reach 0 from their neighbors, thus my problem statement will be reduced to only these much nodes. Okay, let's see. Now how I can figure out which are my neighbors. So 0 neighbors are 1 and 4. If if 1 can reach 0, how 1 can reach 0? By swapping this node, because there is outgoing edges going on. So if I am saying there is an outgoing edge from 0 to 1, do I approaching into this conclusion, like somewhere in my code I need to store the direction of the node. What can be the direction? Either it can be outgoing, either it can be incoming. Correct? So there is a node from 0 to 1 which is an outgoing node. So if I am standing at city 1, can it will be ever be possible I can reach the city 0? No. So I need to swap. Okay, great. So now from if I swap this and there is a incoming node from 4 as well. Okay. So from 1 I can reach 0 and from 4 I also can reach 0. Okay. Now the problem statement become of 3, 2 and 5, fifth node. Okay. So what I am saying now, if I am standing at 3, can I reach a 0 node? No, because 1's neighbor. Now what we did for 0, now the same thing I will do for 1 and 4. I need to check 1's neighbor and 4's neighbor. If one edge or one-th neighbors, one city neighbor, okay, is going into outward direction, okay, the neighbor of city 1 are in outward direction. The node which is going from which is connecting 1 to 3 is in outgoing direction, is in forward direction. So if I am standing at 3, can it ever be possible I can reach 1? Okay, forget about zeroth city problem now, because zeroth city problem we solved by seeing its neighbors. Now the problem become of 1 and 4 to do the replica what we did for 0. And if the node is of outgoing direction, which we can see from the stored information, okay, so that thing which means if it is in outgoing direction, we need to increment our swap count, which means we need to swap that particular edge. Okay, same thing we need to do for 4. Okay, this is also going into outgoing direction, so it means we need to make a swap here. Okay, now the problem statement become of 3 and 5. Okay, what about 3 and 5? Are there any neighbors of 5? No. So there is no other problem statement from 5 we can solve. But there is one neighbor city of 3. So how we can approach this problem statement? The same thing. We will traverse from 3 to 2 and we check the direction of their particular node. That particular node is in incoming direction. So there is no need of swap. Now I will visit here. Now this is my sub problem now. If I am saying this is my sub problem and there is no another neighbor is to traverse, this problem is solved completely. Okay. Now if I am going to visit the neighbors of the nodes, first I traverse from 0 to 1 and 4. From 1 to I traverse 3 and from 4 I traverse to 5 and from 3 I traverse to 2. This is pointing me towards a traversal of BFS. In BFS traversal, I approach the current node neighbors. Okay. If I am approaching towards BFS, I should maintain a visited array, because as per BFS logic, I should not revisit a node again which is already visited. Okay. Now, if I create an adjacency list of this whole graph, I got the information like there is a connection between 0 and 1. But from 0, I do not have a particular information that 0 is connected to 4. So I need to create an adjacency list in that way, like in dual way. Okay, which will store a connection as well as the direction. So for direction, what I can use? Can I create a pair class? So pair will store the node information and a boolean value direction. So what does boolean value means? This is an integer. What I am saying, if it is going in outward direction, I am saying it true. If it is an incoming direction, I am saying it as a false. Okay. So from class pair, I can store all this information and I can create the adjacency list using this pair class. Okay. After creating adjacency list, I need to store all the information to traverse. I need to store the nodes value into a queue. Okay. So let me give you a dry run first. What I'm trying to say, from the adjacency list. Okay. So what does our adjacency list look like? From adjacency list, you will get a lot of idea how we are solving this problem. Okay, let me create an adjacency list. So how many nodes are there? Total 5. Okay, let me scroll little bit down. 3, 4 and 5. Okay, so 0 is connected to 4. Okay, so 0 is connected to 4 and there is an okay, no. Okay, so 0 is connected to 4. 0 is connected to 1. 0 is connected to 1. Okay, and there is an outgoing, so it will store true. Okay, the same thing will store in 1th as well. So 1 is connected to 0, but there is no no, so 0 is connected to 1 with an outgoing branch, but 1 is not connected to 0 with an outgoing branch. So here I will store false. Okay. The next thing is, if I go to the input array 0 to 1, okay, 0 to 1, 0 to 1 is done. Now 1 to 3. Okay, so 1, from 1 there is an outgoing branch to 3 and there is an outgoing branch. Okay, but 3 to 1 there is no outgoing branch. Okay, so in 3 I will store 1 and there will be false. Okay, so the second input is also done. Let me take this 2 to 3. Okay, 2 to 3 there is an outgoing branch, so I will store true. Okay, 2 to 3, so then 3 to 2 as well with the false. Okay, okay, then 4 to 0. What does 4 to 0 means? There is an outgoing branch from 4 to 0. Okay, so I will store true here. The same thing I will do for 0 to 4 with a false. Okay, and the last thing is there is an outgoing from 4 to 5. So from 5, that is true. Okay, and 5 to 4 will be a false. So this is my adjacency list. Now let me create a queue. In queue I will be inserting 0. Okay, I will create a visited array. From this point You will be like getting a lot of information, correct? So I will mark 0 as visited. Now I will check all the neighbors of 0, which is 1 and 4. Okay, I will go to 1. Okay, I will go to 1. 1 and 4 are neighbors. Okay, I will pop out 0. Okay, and they are not visited. I will mark them as visited. 1 and 4 are true. 4 is also visited. What I need to check now, if there is an outgoing branch, what it does mean outgoing edge or outgoing branch or outgoing edge? Like there is a direction going into outward direction, which should not go, it should come in the incoming direction of 0. Okay, so whenever I found a true, I will increment my count. Okay, so let me maintain a count as well. Count is 1. Okay, I will push 1 as well as 4. Okay, great. So I popped out 1. Okay, what are the neighbors of 1? 1's neighbors are 0 and 3. So is 0 is visited? Yes, 0 is visited, so will not visit it again. What I visit are 3. I will mark visit at 3. Okay, I found another true. I will make count plus plus, count will get 2, and I will push 3 into my queue. Okay, 1 neighbors are all traversed. Now I come to visit 4. What about 4? 4 has 0 and 5. 0 and 5. Okay, okay, okay. What I will do now? 0 is already visited. I will not go to 0 again. Okay, now I will go to 5. I will mark them visited. Okay, then I can see there is a true here, so I will increment my count again. It will become 3, and I will add 5 into my queue. That's good. Now I need to traverse 3 neighbors. So 3 neighbors are 1 and 2. I can see 1 is already visited and 2 is already visited. Is 2 is visited? No. So I will mark it visited and add 2 into my queue. So 3 is also traversed. What about 5? I will pop out 5 and check, is it the neighbors of 5 is 4. Is 4 is visited? Yes, so I will not visit it again. I can come to 2, check for 2 neighbors, which is 3. 3 is also visited. So as you can see, my traversal is completed and I can return this count. Let me give you a walkthrough of this code as well. So the same thing, I created a pair, okay, which is storing node and direction. I am creating an adjacency list now. Adjacency list of pair. Okay, and here you can see I am creating a new pair where if it is an outgoing node, I am marking it as true as well as false. I created a constructor here. Okay, then visited of 0 is true. I appended 0 into my queue. Then I doingly BFS call, nothing else. If a neighbor is not visited, then I am marking visited of that neighbor as true. And what does neighbor dot direction means? Neighbor dot direction in the if statement means if neighbor dot direction is equal to true, which we see in the above dry run. So it means it is an outgoing node. I need to swap. So I am incrementing my count and I'm pushing that particular neighbor node into my queue. And if you, I think this video will help you a lot. Let me discuss about the time complexity as well. So I am doing nothing but traversing the whole graph and I am accessing all nodes only once. So order of V plus E. Okay. And if we are not able to understand this adjacency list, let me give you a walkthrough of that as well. What I am doing, adjacency dot get connections of I comma 0. What is I comma 0? If you are given an input array like this 1 2 3 1 2 3. If I take the above example only, the node is going from 0 to 1, 1 to 3, 2 to 3, and 4 to 0, and what else? 4 to 5. So 0 at the adjacency list of 0, I am storing 1 with the direction as true. And in the same thing, what I am doing in the 0, I added 1 with true. In the 1, I am adding 0 with a false. It means simply this thing. Okay, I think that's it. So if you find this video helpful, or if this video helped you to solve or understand this problem statement, so please like the video and try to subscribe my channel. Thank you.